Now, you've already been made aware of our topic for this video, which is about the nature of unsteady state flow regime. Now, why are we relearning this subject again and again since our first years? Why is it so important? Why is it pertinent to our lives? And how on earth does it relate back to us as petroleum engineers? Now, these are just some of the questions that we'll be answering to you today in our video. Now, let's begin with the definition itself. Now, as you can see, an unsteady state flow regime is the condition of a fluid at which the rate of change of pressure at any point in the fluid is not equal to zero, which means that it's not constant. Now, this is in opposition, in contrast to a steady state flow regime whereby the change in pressure remains constant throughout the fluid itself. Now, mathematically, this can be described in this function whereby the pressure gradient, as you can see, is a function of I, which is position, and t, which is time. So what this basically means is that the pressure changes at any point in the reservoir throughout time. Now, okay, this can also be shown in our graph, okay, in a pressure versus time graph, when as you have three different states, but the one that we'll be observing today is the unsteady state flow. As you can see, as time gradually increases, the pressure tends to decrease, but there is no observable pattern at which the pressure decreases. That is why we state that at any point in the reservoir or in the fluid, the pressure change is not equal to zero.
For a better understanding about unsteady state, let us explain you through an analogy. Let's go.
Before we go to unsteady state, let me show you a little of steady state for a better understanding of the analogy. Yeah, that's me, studying for my RE test 1 without any disturbance in a calm situation. My mood of studying was not disturbed or distracted, and it remained constant throughout the time I was studying. Let us replace my study mood with the reservoir pressure. In steady state, the pressure at every location in the reservoir remains constant and does not change with time. Wow, look, I have gotten an A+ for my test 1. Next, let's go for unsteady state. That's me again studying for my RE test 2. This time, my studying mood was not constant. As you can see, I do face some disturbance due to my mobile phone and also my friends. This disturbance causes my study mood to be not in a constant state. This is how we can relate to unsteady state flow, where the rate of change of pressure with respect to time at any position in the reservoir is not zero or constant. Sadly, this time I have failed my test too.
So talking about the unsteady state real life examples, we can take the example of a lake. Here we have an UPP. As you can see, the lake is under the influence of rain or wind, which are weather conditions, causing the lake to be unsteady. Because of the difference in pressure variations, the lake is going to have rate of change of different pressure along the different time and part of the lake. Similarly, if you compare the same lake being steady, there's no weather conditions at all, and it's not raining, it's a dry day, and the condition of the lake is stable, which means there are not a lot of pressure variations. So this is the real life example you can take between an unsteady state and a steady state reservoir.
Well, we have already covered on the introduction part, a simple analogy and also a real life application of an unsteady state. Well, as a petroleum engineering student, how does this affect in a typical reservoir situation? For that, let us go through to an animation video.
So, during the production, the wellbore pressure is lower than the reservoir pressure, which can be separated based on the boundaries. The region near to the wellbore travels out the fluid to the wellbore. This thus reduces the pressure at the region. The outer region where the pressure is higher pushes out to the wellbore too. This is a continuous process as the production is going on. As we know, unsteady state condition may be occurred by environmental factors such as wind and rain. This will eventually affect the pressure, time, porosity and also the permeability. So, as mentioned earlier, the unsteady state flow could be described in this equation where the change of pressure over time does not equal to zero or constant.